In this video, we'll derive the three equations of motion from the physics syllabus. Equation 1, equation 2, and equation 3. Make sure that you're familiar with the symbols used for the variables in these equations. We'll start with equation 1. This is derived from the equation for acceleration. This notation here means change in velocity. So delta V, or change in velocity, equals the final velocity minus the initial velocity. So we can also write this equation like so. Let's now relate this formula for acceleration to the velocity time graph. The rise is given by the final velocity minus the initial velocity. The run is given by the time. So the gradient of the graph gives us acceleration. So this equation can be rearranged to find our first equation of motion. I'll step this out slowly. We firstly times both sides by t, then we add u to both sides, and then you can just flip this around. And here we have our first equation of motion. Now let's just bring our attention back to the graph and how this equation relates to the graph. If we then rearrange this equation just slightly to this form, we can compare it to this equation for a straight line, which you should be familiar with from maths. So the y and the x relate to the values on the y and x axes, in this case velocity and time. The m represents the gradient, which in this case we've shown to be acceleration, and the b is where the line crosses the y-axis, which is in this case, you'll see, where the initial velocity is. So if the initial velocity is 0, this line would look something like that.